Hello students, question number 29 is from test series 1, subject engineering mechanics and chapter dynamics, and it is of 2 marks. The question says that the maximum value of moment that can be applied on a solid cylinder about its centroidal axis such that motion is pure rolling. Coefficient of static friction is 0.2 and mass of the cylinder is 10 kg and diameter 1 meter. So we have to find the maximum value of the moment. Now consider the solid cylinder which is at rest. The radius of the cylinder is r and the total forces on the cylinder is the weight of the cylinder which is mg, and the reaction force at the contact surface is n. The friction force acting on the cylinder is F. We have to find the value of the moment m. Now pure rolling. Pure rolling is the rolling motion in which sliding doesn't occur. Only pure rolling motion occurs. And we will consider the forces on the cylinder. Equating the horizontal forces which is equal to mass into acceleration. The horizontal forces is friction force which is F. F is equal to ma. We will get the equation 1. Now considering the moments on the cylinder, we will take clockwise moments. M0 will be I0 alpha, where I0 is the moment of inertia about the centroidal axis and alpha is the angular acceleration. So we will get the equation m minus f into r, because the moment about the friction force about the centroidal axis will be f into r. So m minus fr is equal to I0 alpha. We will consider this as equation 2. Now considering the vertical forces to 0, we have only reaction n and weight of the cylinder. So we will get n is equal to mg. We will take this as equation 3. So now for pure rolling, acceleration will be equal to r into alpha, where alpha is the angular acceleration. Now combining equation 1 and 4 in equation 2, we will get m is equal to fr plus I0 alpha. This is equation 2. So now for a cylinder, I0 value will be mr square by 2. Substituting this here, and from equation 1 and equation 4, we will get the value of alpha as f by mr. So now the final equation for the moment on the cylinder is 3fr by 2 in terms of the friction force and the radius of the cylinder. Now to find the maximum value of the moment m, here the maximum value which can take is only the friction force. So the friction force to be maximum, it has to be at the only limiting value of the static friction, which is F max will be mu into n, where n is equal to mg. We will get this from equation 4. So F is equal to mu mg. Now substitute this in equation of m. We will get the value of m as 3 by 2 into mu mg into r. So the mass of the cylinder is given as 10 kg, g is acceleration due to gravity which is 9.81, and r is the radius of the cylinder. As diameter is 1 meter, we will get r as 0.5 meter, and mu is the coefficient of friction which is given in the question as 0.2. So we will get the final answer of maximum value of moment as 14.7 Newton meter. And this is the final answer. Thank you.